Alright. So machining is described as any set of various processes where a raw material is cut into a desired shape by controlled material removal. That's called subtractive manufacturing, which you can kind of think of as like the inverse of 3D printing. So if you have like a block of steel, then you're using machines to take away different layers. So it's like the opposite of a 3D printer. So 3D printing is an example of additive manufacturing, and there are three main types of machining. So there's manual machining, which is more like skill-based, and you're using your hands through like lathes and milling machines. And then there's CNC machining, which is computer numerical control, which is like a computer program attached to a milling machine. And then there's some other unconventional methods. So if you think about it, there's machine products everywhere in your daily lives and everywhere in like manufacturing, everything from your iPhone to like the aluminum can you're drinking, or even like the chair you're sitting in. So if you start thinking more about the origins of like your daily objects, then you start to realize how important machining is and how ubiquitous machined products are. Like something along the line has been touched by one of these types of machines. So I worked at a machine shop in Oakland called Diamond Tool and Die, and mostly I would do cleaning and like driving the forklift, and I learned a lot about machines, and it's really like interesting to see just like what they were making and how it, you don't think about like the tortilla chip oven that we had to like make parts for, or like if anyone's from the Bay Area, there's BART trains, and then like in the tunnels of the BART trains, they need to have like air circulators for like with fans and stuff. So there's a lot of stuff like that that you don't think about all the time, but it's a very necessary part of our society. So fields like aerospace, medical, transportation, food manufacturing, and pretty much any field relies heavily on machine shops like Diamond Tool and Die, which is a pretty small operation. And if you think about it, like China's manufacturing is essentially all just machine shops like this creating different products. Because if you have a CNC machine, you can create literally like anything. So this is like a milling machine that we would have at Diamond Tool, and as you can see, there's like little metal inserts that are made out of carbide or like really hard metal. So you spin the milling machine really fast and it starts cutting those metal chips you see off. And my job, one of the biggest parts was just cleaning up all the metal chips on the ground, and like there's a lot of them. And so you can see like those little blue tubes, those are for like coolant and air to like spray on the workpiece, and coolant and oil that gets really messy too, so I was cleaning all of that up. And then, so some of my main points are there's many different types of machining, and machine products are ubiquitous and can be found everywhere, and they're very necessary to overall how our society works. And three, the machining industry should be expanded in the United States, and places like China are very polluted because of their practices, and we should work to change that. So in Sam Jones' 1985 article in the American Metal Market publication, he talks about how manual machining can be the most innovative and finesse required. So in that article, they talked about how manual machining helps shape an artificial heart. And even though that article was from 1985, it's still relevant because like the finesse required in using like milling machines and like working with your hands is still a lot more precise than a computer just doing all the work for you. So this is just a forklift and pallets. Like we would make all these parts, and then I'd have to palletize them and put them onto pallets. So moving on, the vast variety of machines just leads to show like how machines work. It can help you begin to understand the processes. So these are just milling machines, and if you think about it, if you've ever used a drill press, it's just a drill press that moves vertically, and you can move the workpiece on like an axis, so like an XY axis. And then if you think about it, you can make pretty much anything from that, and that's just like a CNC machine without the computer numerical control, which is just controlling like the different coordinates on the axis. So this is a metal lathe, and if you've ever been in like wood shop, then you know a lathe is like you can turn a piece of wood and make like a baseball bat or something like that, and it's the same concept just with metal. So at my machine shop, the guys working on the lathes would be making these huge, like sometimes like 20 feet long, like 2-ton metal tubes, which I don't know exactly what they're for, but any like pressure vessels and all this stuff is all made from lathes somewhere down the point. So also in the International Journal of Advanced Manufacturing Technologies 2018 article, the digitization, modeling, and CNC machining for cone-generated worm drives, they talk about CAD programs, which are computer-aided design programs, which is basically the precursor to putting like a program into a CNC machine, which is just like running through all of the coordinates for you. So this is a CNC machine. You can see like the control board, how there's a lot of different buttons and dials, and that's all. It seems pretty simple, but like most of the real work goes into the computer-aided design software before you even go into the machine. And again, it's just like a CNC machine you can think about is like a lathe, and it's like a milling machine. It's just connected to a computer. So it does all the work for you, essentially. So furthermore, in the Applied Physics Letters 2013 article titled "The Laser Machine Microresonators for Nonlinear Optics," the author talks about an unconventional method of CO2 laser lathe machining. So there's a lot of unconventional methods of machining, like laser machining or electric discharge machining, called EDM machining, and that's like really complicated stuff. We had one of those machines at Diamond Tool, and there's like these super thin copper strands that something about the electronics like splits the atom of the metal piece you're working on, so it's really precise, and it's not like a physical saw cutting through the metal. It's like a chemical reaction. And then, as you can see, there's an example of laser cutting, which is a lot of stuff is being made with that. Or like if you've ever seen the super high-powered water pressure cutting into metal, those are some examples of unconventional machining. So talking more about general processes, those are again the carbide metal inserts, and machinists have to change those constantly because they're always wearing out. And then there's like an oil gun. There's a lot of lubrication that you need to do when you're cutting metal with another piece of metal, as you could imagine. So also in the Journal of Alloys and Compounds 2015 article called "An Investigation of Mechanical Properties of Material Removal Rate," the author talks about how like electric discharge machining has to be very precise at how much material it removes, and all these sorts of jargon and terms about precision and material removal rates. So there's a lot of math and computer stuff that has to be very precise. So this is, you can see this guy is cleaning up like a coolant tank with a bunch of metal chips in it, and that was another part of my job, which was really dirty and tedious. And so there's a lot of dirty coolant and oil that is a product of machining, which is a big source of pollution, and we had to put it into special buckets and make sure like none of it got into the gutter, because a lot of machine shops prior to a certain year just kind of threw that stuff into the gutter. And again, the machine shop I worked at was probably a few hundred feet away from the bay, so right next to water is bad. And then this is an oil spill, another thing that I would have to clean up. So the third most important thing about machining is the pollution, like I talked about, and how places in China and like Southeast Asia have dominated the manufacturing sector. So in the Journal of Cleaner Production's 2017 article, an interoperable energy consumption analysis system for CNC machining, some main points were energy efficiency and environmental well-being. And it would just talk about like an analysis system for CNC machines that helped cut down energy waste and be more efficient overall. So you can see these like fume hoods on the machines. Those capture the exhaust and send it through like a ventilation system, I guess. And then it like there was a lot of like oil and like really gross stuff. So there's a lot of potential for pollution when it comes to machining. And then there's like a bucket of waste oil where we would have to just I don't know exactly what happened to it, but you have to be very careful about like where you're putting all the waste oil, and so it doesn't get into the environment. And that's another fume hood, like capturing the exhaust and the fumes. So finally, in the 2012 Tribune Business Weekly article called "A New Calibration," the author talks about going to a convention about manufacturing production in China, and it talked about how at a certain point the production in China would have to like reach a critical mass, and then essentially that we need to start investing more into like education about machining and jobs in the U.S. for machining. And I really agree with that, because I can see how machining is a very like honorable career, I think, and a lot of the guys who work in the machine shop are really smart, and I learned a lot. So thank you, and I hope you learned some more about machining.